Good evening students, this is Siddhav Sakhalkar here, and today we will be learning the third and the final sum of the topic of fixed beam. We have learned two sums so far, which is when both the ends of a beam are fixed and there is a only UDL on it. Then when both the ends are fixed and there are 2 point loads on it. So you learned that you have to convert UDL into a point load, and the rest of the sum is same. Now we'll be learning the third and the final sum of the fixed beam, which has been asked in Indira College of Architecture exam sample paper. So this is this sum. If both the ends of a beam are fixed and there are 2 point loads acting on it, also there is a UDL on it. So what do you do in this sum? So step number 1 is that finding support reaction. So you know how to do it, considering the beam as simply supported. So step number 2 I'll be teaching you is that what you will be doing is that there are 2 point loads in the center C and D. You will be finding moment at C and moment at D. So as you know that our sign convention from left to right is clockwise positive. So moment at C. So if you see from this support A till C, there are two forces acting. First, RA is acting in the clockwise and this UDL is also acting here in the anti-clockwise towards point C. So it comes out to be moment at C is equal to RA into 2.5 clockwise, hence it is positive, minus 2 into 2.5 multiplied by 2.5 divided by 2. So it comes out to be 2 into 2.5 square upon 2. The answer at moment at C comes out to be 35.375 kilonewton meter. Now moment at D. If you see from A to D, there are three forces acting. First, RA is acting over a span of 3.5 meter. Then this 10 kilonewton is acting over a span of 1 meter. And this UDL is acting over a span of 3.5 meter. So I have shown it here. RA into 3.5. So RA into 3.5 comes out to be positive. Then minus 10. 10 kilonewton force is taking an anti-clockwise moment towards point D. So it comes out to be minus 10 into 1 meter. And there is a from A to point D, there is a UDL acting over a span of 3.5 meter. So it comes out to be 2 kilonewton multiplied by 3.5 multiplied by 3.5 square upon 2, which comes out to be 2 multiplied by 3.5 square upon 2. So thus moment at point D comes out to be 36.025 kilonewton meter. And step number 3, final step, is we have already seen in the first two sums, we were saying what are the formulas for fixed beam when there is a point load acting. So the only difference between this previous sums and this sum is that what is the formula for fixed beam when there is a UDL acting. In this sum there is no need for converting UDL into point load. So let's keep UDL as it is. So there are just two formulas which we learned previous so far, is that this fixed beam sum will be splitting into three parts. In this table, this is the loading, moment at A and moment at B. So for the first beam, we will be isolating 10 kilonewton load, then we'll be isolating again 10 kilonewton load which comes out second time, and then we'll be isolating this entire UDL. Okay? So first, as we have seen previously, this 10 kilonewton load, if we are taking this load as first load, it is acting at a distance of 2.5 meter from left side and at a distance of 3.75 meter from the right side. So the moment at A formula comes out to be minus WAB square upon L square. This distance is A and this distance is B. So W, so 10 multiplied by 2.5 multiplied by 3.5 square upon L. L comes out to be the addition of 2.5 and 3.75. For moment at B, it comes out to be exactly opposite, minus W B 3.75 multiplied by A 2.5 square upon L square. The formula will remain the same for this second step, just that the distance is different. So for this 10 kilonewton load, it is acting at a distance of 3.5 meter from the left side and 2.75 meter from the right side. So L, the length you will take as addition of 3.5 and 2.75 meter. And so the only new thing in this sum to be studied, students, is that when there is a uniformly distributed load in this fixed beam method, it is the moment at A and moment at B. First of all, the formula comes out to be the same. It's minus WL square upon 12. So W is 2 kilonewton per meter multiplied by L. L is the whole span 6.25 square upon 12, and moment at B also will remain the same. After this, you, as I already shown in the previous videos, you'll be adding all these three answers. All the three answers comes out to be with the negative values. You'll be adding all these three answers, and this will, here you will be getting the answer for moment at A, and here we'll be getting the answer for moment at B. So these answers are the fixing moments at A and B. Okay students, so we have studied all the three sums on fixed beam so far. You know how to draw support reaction, shear force diagram. All the best students, do well, take care.